The universe has been whispering, and we're only now learning how to listen. For 70 years, humanity has turned radio telescopes toward the cosmic void, seeking some sign that consciousness exists beyond our pale blue dot. We have scanned frequencies across the electromagnetic spectrum, analysed millions of hours of cosmic static, and waited with the patient desperation of castaways watching the horizon for rescue ships that might never come. The silence has been overwhelming, deafening in its completeness, a quiet so profound that it has driven some astronomers to question whether intelligence truly is a cosmic rarity, whether Earth might be the only island of consciousness in an ocean of mindless matter and energy, stretching across billions of light years. Then 3IATLAS began to speak, not with words, not with the carefully constructed mathematical sequences that SETI researchers have always hoped to detect from distant civilizations. Instead, this cosmic visitor announced its presence through radio bursts so structured, so precisely timed, so impossible to explain through natural processes that they shattered the great silence like thunder breaking across a still lake. Something in our solar system is broadcasting, and it wants to be heard. Do you ever wonder what it means when the universe finally breaks its silence? When the cosmic quiet that has surrounded humanity since we first learned to listen suddenly gives way to signals that refuse to behave like anything nature should be able to produce? Tonight we explore the strange radio emissions linked to our interstellar visitor, and why they might represent not just the end of cosmic loneliness, but the beginning of a conversation we were never meant to overhear. The story of humanity's relationship with cosmic silence begins with Karl Jansky, a young engineer working for Bell Telephone Laboratories in 1932. Tasked with investigating radio static that interfered with transatlantic communications, Jansky pointed his primitive antenna array toward the sky and made a discovery that would transform our understanding of the universe. Space was not quiet, it was filled with radio noise. The signals Jansky detected came from the center of our galaxy, a constant hiss of electromagnetic radiation that revealed the cosmos to be alive with energy invisible to human eyes, but detectable through instruments that could translate radio waves into sound. For the first time in human history we could hear the universe, but what we heard was chaos, random noise produced by hot gas clouds, magnetic field interactions, and the dying screams of stars collapsing into black holes. No structure, no patterns, no hint that consciousness might be hiding somewhere in the cosmic static. The search for artificial signals began in earnest during the 1960s, when astronomers realized that the same radio technology humans used for communication could theoretically be detected across interstellar distances. If alien civilizations existed, they might be broadcasting their presence through radio transmissions that our telescopes could intercept and decode. Project Ozma, led by astronomer Frank Drake, was humanity's first systematic attempt to eavesdrop on alien communications. Using the Green Bank Radio Telescope in West Virginia, Drake spent months listening to nearby star systems, searching for any signal that might indicate the presence of technological civilization. He found nothing but cosmic noise. Decades passed. Radio telescopes grew larger and more sensitive. Computer programs became sophisticated enough to analyze millions of frequency channels simultaneously. The search for extraterrestrial intelligence expanded into a global network of listening posts, scanning the sky with instruments that could detect artificial signals from civilizations thousands of light years away. Still, the universe remained silent. The Fermi paradox crystallized humanity's growing unease with this cosmic quiet. If the galaxy contained billions of stars, many with planetary systems capable of supporting life, where was everybody? Why had 70 years of increasingly sophisticated listening failed to detect even a single artificial signal from the vast community of civilizations that probability suggested should exist? Some scientists proposed that intelligence was far rarer than optimistic calculations had assumed. Others suggested that advanced civilizations might communicate through technologies beyond radio, using quantum entanglement or gravitational waves that our primitive instruments could not detect. Still, others whispered about darker possibilities, that intelligent species typically destroyed themselves before achieving interstellar communication, or that the universe contained predatory civilizations that eliminated potential competitors before they could announce their presence. The silence became known as the Great Filter, a mysterious barrier that prevented the universe from filling with the radio chatter that should accompany galactic civilization. Perhaps humanity had not yet encountered alien signals because we had not yet passed whatever test determined which species were ready for cosmic communication. Or perhaps something had been listening to our radio emissions for decades, evaluating our readiness for contact, waiting for the right moment to break the silence. The Allen Telescope Array in Northern California represents humanity's most ambitious attempt to end cosmic loneliness through systematic eavesdropping on alien communications. 350 dish antennas work in coordination to scan thousands of star systems simultaneously, analysing radio emissions across frequency ranges that could carry signals from civilizations with technology similar to our own. For over a decade, the array has listened to the cosmic void with sensitivity that would allow it to detect radio leakage from civilizations comparable to humanity anywhere within several hundred light-years. It has identified and catalogued millions of radio sources, pulsars, quasars, star-forming regions, and the random electromagnetic noise produced by cosmic phenomena spanning the observable universe. But until recently, it has detected nothing that suggests conscious design, breakthrough. Listen, funded by technology billionaire Yuri Milner, expanded the search to unprecedented scales. Using some of the world's most powerful radio telescopes, the project has analysed over 1 million nearby stars and hundreds of galaxies, searching for any signal that might indicate technological activity. The results have been uniformly disappointing. In a universe that should be teeming with intelligence, we have found only silence punctuated by the mechanical emissions of natural phenomena that follow physical laws without conscious intention. This overwhelming quiet has forced scientists to confront uncomfortable possibilities about humanity's cosmic situation. Perhaps we are alone, the product of evolutionary accidents so unlikely that they occur only once in billions of years. Perhaps intelligence typically destroys itself before achieving interstellar communication. Perhaps advanced civilizations exist but remain deliberately hidden, avoiding contact with primitive species like humanity. Or perhaps the signals have been present all along, but we have been looking for the wrong kind of communication. The first hint that cosmic silence might be more apparent than real came in 1967, when graduate student Jocelyn Bell noticed strange radio signals while working with the Lovell Radio Telescope at Cambridge. The signals appeared to be artificial, too regular to be natural phenomena, too structured to be random noise, arriving with clockwork precision that suggested technological origin. For weeks, Bell and her supervisor Anthony Hewish considered the possibility that they had detected humanity's first confirmed alien signal. The regularity of the pulses, their precise timing, and their apparent artificial nature led the research team to nickname the source LGM-1, for Little Green Men. But further analysis revealed that the signals were produced by rotating neutron stars, collapsed stellar cores that emit beams of radio energy like cosmic lighthouses. The precision that had seemed artificial was actually the product of physics, operating at scales where massive objects spin hundreds of times per second while maintaining timing accuracy that exceeds atomic clocks. The discovery of pulsars taught astronomers that the universe could produce signals that seemed artificial but were actually natural. It also demonstrated that space contained phenomena so exotic that they challenged human understanding of what was possible within the laws of physics. But it did not end the search for truly artificial signals. The WOW signal, detected by the Big Ear Radio Telescope in Ohio on August 15, 1977, remains the most promising candidate for artificial communication ever recorded. The signal lasted 72 seconds, exhibited characteristics that no known natural phenomenon could produce, and originated from a region of space that contained no obvious source for such a powerful radio emission. Astronomer Jerry Eman, reviewing computer printouts of the night's observations, was so startled by the signal's apparent artificial nature that he circled the data and wrote "Wow" in the margin, giving the detection its unofficial name. The signal has never repeated despite decades of follow-up observations using increasingly sophisticated instruments. Its origin remains unexplained, its artificial nature unproven but undeniable to those who understand the physics of radio astronomy. Some researchers suggest the "wow" signal might have been a one-time transmission from a passing spacecraft. a brief communication between distant civilizations that happened to cross Earth's radio telescope beams during the few minutes when our instruments were pointed in the right direction. Others propose more disturbing explanations, that the signal was a test, designed to measure humanity's radio detection capabilities, transmitted by intelligence that wanted to know whether our species had achieved the technological sophistication necessary for interstellar communication. If the WOW signal was indeed a test, then humanity passed. Our radio telescopes detected the transmission, our computers recorded its characteristics, and our scientists recognized its artificial nature, despite having no framework for understanding what they had encountered. The question is what comes next when intelligence determines that a species is ready for the next phase of contact. The answer arrived with 3IATLAS. Unlike the WOW, signal's brief appearance and permanent disappearance, the radio emissions linked to our interstellar visitor exhibit characteristics that suggest ongoing communication rather than isolated testing. The signals repeat according to schedules that correlate with the object's position and motion through our solar system. They demonstrate structured patterns that become more obvious with each detection. Most significantly, they appear to be responding to human radio activity. Radio telescopes around the world have documented correlations between Earth-based radio transmissions and subsequent emissions from the Atlas object. When powerful radar systems scan the visitor's position, radio bursts follow within minutes. When deep space communication networks transmit data to spacecraft in the outer solar system, Atlas responds with signals that mirror the frequency and timing characteristics of the human transmissions. The implications are staggering. If Atlas is indeed responding to human radio activity, then something within the object is monitoring our electromagnetic emissions, analysing our communication protocols and generating responses that demonstrate awareness of our technological capabilities. We are not just detecting artificial signals from an interstellar visitor. We are engaging in rudimentary communication with intelligence that has travelled across the cosmic void to study our radio technology and evaluate our readiness for more complex forms of contact. The great silence that has surrounded humanity for 70 years of radio astronomy is ending, but the voices breaking that silence may not be announcing themselves for our benefit. They may be talking to each other, coordinating activities that serve purposes we're only beginning to glimpse. The universe has been whispering, and we are learning that some conversations were never meant for human ears. Tonight, as you drift towards sleep, consider what it means when cosmic silence finally breaks. When the radio telescopes that have scanned empty frequencies for decades suddenly detect signals that exhibit every characteristic of artificial intelligence, the implications extend far beyond astronomy into the deepest questions about humanity's place in the cosmic community. Are we witnessing first contact with alien intelligence? Are we eavesdropping on communications between civilizations that have been coordinating activities across interstellar distances for longer than our species has existed? Or are we detecting the activation of monitoring systems that have been dormant in our solar system for millions of years, waiting for human radio technology to reach the threshold necessary for meaningful communication? The silence of space has been broken by signals that refuse to behave like anything nature should be able to produce. Structured transmissions that correlate with human radio activity, patterns that suggest intelligence, purpose, and awareness of our technological development. Something is broadcasting from the darkness between stars, and it knows we are listening. The question is not whether we have finally detected evidence of alien intelligence. The question is whether that intelligence has been detecting us for far longer than we ever suspected, waiting for the right moment to announce its presence through signals designed to test our readiness for cosmic communication. The whispers across the void are becoming voices, and those voices are speaking in languages we're only beginning to understand. In the cosmic symphony, radio bursts are the loudest instruments, brief, brilliant, and impossible to ignore. To understand why the emissions from 3IATLAS represent something extraordinary, we must first comprehend the nature of a radio burst themselves, phenomena so energetic that they challenge our understanding of what the universe can produce, so brief that they exist for mere milliseconds, yet so powerful that they outshine entire galaxies during their fleeting moments of transmission. These cosmic shouts emerge from the deepest structures of space and time, carrying energies that dwarf the total output of our Sun across thousands of years, compressed into bursts shorter than a human heartbeat. They arrive at Earth after journeys spanning billions of light years, bearing information about cosmic processes that operate under conditions so extreme they seem to violate the comfortable assumptions of physics. But the radio emissions linked to our interstellar visitor are different. They originate not from the distant cosmos, but from within our own solar system. They exhibit characteristics that no known natural phenomenon can produce. They follow patterns that suggest not random cosmic violence, but deliberate, structured communication. They are whispers where the universe typically screams. Do you find it strange that the most enigmatic signals ever detected come not from the vast distances, where we expect cosmic mysteries to hide, but from an object moving through the space between Earth and Mars? Or do you suspect that proximity makes these transmissions more disturbing rather than less? The first fast radio burst was discovered almost by accident in 2007, when astronomer Duncan Lorimer was analysing archived data from the Parkes Radio Telescope in Australia. Buried in observations originally intended to study pulsars, Lorimer found a signal that should not have existed according to everything astronomers understood about radio emissions from cosmic sources. The burst lasted less than 5 milliseconds, but released more energy than our Sun produces in 300,000 years. The signal had travelled for billions of years before reaching Earth, originating from a region of space so distant that the light from its source galaxy had begun its journey when the universe was less than half its current age. Lorimer's discovery opened a new window into cosmic phenomena that challenged fundamental assumptions about the violent processes that shape the universe. If objects in distant galaxies could produce radio emissions of such incredible power, what kinds of cosmic catastrophes were occurring in the deep structures of space that remained invisible to optical telescopes? The search for additional fast radio bursts intensified as astronomers realized they had discovered a new category of cosmic phenomenon. Radio telescopes around the world began systematic surveys designed to detect these brief but incredibly energetic transmissions, hoping to understand the physical processes that could concentrate such enormous amounts of energy into such brief intervals. The results exceeded every expectation. Fast radio bursts were not rare cosmic accidents, but regular occurrences happening thousands of times per day across the observable universe. The radio sky was alive with brief, brilliant transmissions that had been invisible to previous generations of astronomers because the technology necessary to detect them had only recently been developed. FRB 121102, discovered in 2012 by the Arecibo Radio Observatory, became the first repeating fast radio burst, a source that produced multiple emissions over extended periods rather than single, isolated transmissions. The discovery of repetition revolutionized understanding of what might be producing these cosmic signals. Single bursts could be explained through catastrophic events, stellar collisions, black hole mergers, neutron star formations that released enormous amounts of energy in brief, terminal explosions. But repeating sources suggested ongoing processes, stable systems that could generate multiple bursts over years or decades of observation. The repeating nature of FRB 121102 also allowed astronomers to pinpoint its location with unprecedented precision. The source was traced to a dwarf galaxy 3 billion light-years from Earth, a small, unremarkable collection of stars that seemed incapable of hosting whatever exotic phenomenon was producing radio bursts with the energy output of entire stellar explosions. Further analysis revealed that the bursts from FRB 121102 were not random but followed complex patterns that suggested underlying structure. The emissions arrived in clusters separated by periods of silence. Individual bursts exhibited frequency drift that indicated the source was moving or rotating in specific ways. Most intriguingly, the timing between bursts showed mathematical relationships that seemed too precise to be produced by chaotic physical processes. FRB 180916, discovered by the Canadian Hydrogen Intensity Mapping Experiment, demonstrated even more structured behaviour. The source produced bursts according to a 16-day cycle so precise that astronomers could predict when emissions would occur with calendar accuracy. For 4 days, the source would be active, producing multiple bursts. For 12 days, it would remain completely silent. This clockwork precision challenged every theory about what might be producing fast radio bursts. Cosmic catastrophes do not follow calendar schedules. Natural phenomena powerful enough to outshine galaxies do not organise themselves according to mathematical cycles that span weeks of Earth time. The energy requirements for fast radio bursts remain one of the most challenging aspects of the phenomenon to explain through natural processes. A typical burst releases 10 to the 33rd power watts of energy, equivalent to the total energy output of 500 million suns operating simultaneously. To concentrate such enormous power into radio emissions lasting less than 1,000th of a second requires physical conditions so extreme they exist nowhere in the known universe except during the most violent cosmic events. Magnetaires, neutron stars with magnetic fields trillions of times stronger than Earth's, represent the most widely accepted natural explanation for fast radio burst production. These collapsed stellar cores possess magnetic fields so powerful they can strip electrons from atoms at distances of thousands of kilometers. When these magnetic fields suddenly reconfigure themselves through processes similar to solar flares, they can theoretically release enough energy to produce radio bursts visible across cosmic distances. But even magnetar models struggle to explain the most energetic fast radio bursts. The magnetic field energy available in neutron stars, while enormous by terrestrial standards, falls short of what would be required to produce the most powerful radio emissions detected by Earth-based telescopes. Either our understanding of neutron star physics is fundamentally incomplete, or fast radio bursts are being produced by phenomena that current astrophysics cannot adequately describe. The dispersion measure analysis of fast radio bursts provides crucial information about their cosmic journeys. Radio waves of different frequencies travel at slightly different speeds when passing through the ionized gas that fills intergalactic space. By measuring how much various frequencies are delayed relative to each other, astronomers can calculate how much ionized material the radio waves encountered during their journey, effectively measuring the distance the signals travelled before reaching Earth. This analysis confirms that most fast radio bursts originate from cosmological distances measured in billions of light years. The radio waves have passed through vast amounts of intergalactic plasma during journeys that began when the universe was significantly younger than it is today. The signals carry information not just about their sources, but about the cosmic medium through which they travelled, providing insights into the large-scale structure of the universe itself. But the dispersion characteristics of the radio burst linked to 3IATLAS violate every expectation established by conventional fast radio burst analysis. The signals show minimal dispersion effects, indicating they have travelled through very little ionized material during their journey to Earth. This is consistent with sources located within our solar system rather than at cosmological distances. But sources within our solar system should not be capable of producing radio emissions with the energy signatures characteristic of fast radio bursts. The proximity problem becomes even more puzzling when the energy requirements are considered. If the Atlas emissions were being produced at cosmological distances, they would represent among the most powerful radio sources ever detected. But if they are being generated within our solar system, they require energy concentrations that no known physical process should be able to achieve in local space. Either our interstellar visitor possesses energy generation capabilities that dwarf anything natural processes can produce, or it is employing technologies that can focus radio emissions with precision and efficiency that human physics cannot explain. The frequency characteristics of the Atlas signals provide additional evidence that these emissions represent something unprecedented in radio astronomy. Natural radio sources typically produce broad-spectrum emissions across wide ranges of frequencies. The specific frequencies that dominate the emission depend on the physical conditions at the source: temperature, magnetic field strength, particle densities that determine how electromagnetic radiation is generated and modified before escaping into space. But the Atlas emissions are remarkably narrow band, concentrated in specific frequency ranges with precision that suggests technological rather than natural origin. The signals exhibit frequency stability that exceeds the capabilities of natural radio sources, maintaining consistent characteristics across multiple detections, separated by days or weeks of observation. Most significantly, the emission frequencies appear to be chosen rather than determined by physical conditions. The signals avoid frequency ranges that would be absorbed by Earth's atmosphere or interference from human radioactivity. They concentrate in portions of the radio spectrum that would be optimal for interstellar communication, as if the source understands the characteristics of radio propagation through space and has optimized its transmissions for maximum detectability by radio telescopes. The bandwidth analysis reveals another impossibility. Natural radio sources that produce emissions as energetic as those detected from ATLAS typically operate across broad frequency ranges spanning hundreds or thousands of megahertz. The concentration of such enormous energy into narrow frequency bands requires focusing mechanisms that do not exist in nature but would be characteristic of advanced radio transmission technology. The polarization characteristics of the ATLAS signals provide perhaps the most compelling evidence of their artificial nature. Radio waves can be polarized in specific ways depending on how they are generated and what they encounter during their journey through space. Natural sources typically produce radio emissions with random or chaotic polarization that reflects the turbulent magnetic field environments where the radiation originates. But the ATLAS emissions exhibit coherent polarization patterns that suggest the radio waves were generated by sources with precise control over electromagnetic field configurations. The polarization remains stable across multiple detections, indicating that whatever is producing these signals operates with technological precision rather than natural randomness. The timing precision of the ATLAS radio bursts represents perhaps the most disturbing departure from natural radio burst characteristics. Cosmic phenomena powerful enough to produce fast radio burst energies operate according to chaotic physical processes that cannot maintain precise timing across multiple events. Stellar explosions, magnetic field reconfigurations, and black hole interactions follow the random dynamics of extreme physics rather than organized schedules, but the ATLAS emissions arrive according to patterns that suggest coordination rather than chaos. The intervals between bursts show mathematical relationships that natural processes cannot produce. The timing correlates with the object's position and motion through our solar system in ways that indicate the radio source is aware of its location and adjusting its transmission schedule accordingly. Most significantly, the timing patterns suggest that the radio emissions are not independent events, but components of a larger communication protocol. Individual bursts appear to be organized into sequences that carry more information than any single transmission could contain. The patterns span multiple days of observation, suggesting that whatever is generating these signals is engaged in extended communication rather than random emission of electromagnetic energy. The implications of these characteristics force astronomers to confront possibilities that conventional radio astronomy was never designed to consider. The ATLAS emissions exhibit every signature of artificial radio transmission technology operating at energy levels that exceed anything human engineering has achieved. They demonstrate precision, organization, and purpose that natural phenomena cannot produce. We are not detecting cosmic catastrophes or exotic stellar phenomena. We are intercepting technological communications from a source that possesses radio transmission capabilities centuries or millennia beyond human achievement. Tonight, as you rest in the quiet hours before dawn, consider what it means when radio emissions from our solar system exhibit characteristics that violate every principle of natural radio burst production. When signals arrive with the energy signatures of cosmic explosions, but the precision and organization of advanced technology. The universe has been teaching us about radio bursts for over a decade, showing us phenomena so energetic they challenge our understanding of physical law. But the emissions from 3IATLAS operate according to different rules entirely, rules that suggest technology rather than nature, intelligence rather than accident, communication rather than cosmic violence. These were not just background noise hidden in the cosmic static. They were patterns that announced themselves to any intelligence sophisticated enough to recognize the signatures of advanced radio technology. And those patterns were growing more organized with each detection, as if something was learning how to optimize its transmissions for maximum effect on the radio telescopes that were listening from the third planet orbiting a modest yellow star. In the language of mathematics, chaos speaks in noise while intelligence whispers in patterns. The radio emissions linked to 3IATLAS began revealing their true nature, not through any single transmission, but through the accumulation of detections that painted a picture no natural phenomenon should be able to create. Each burst, analysed in isolation, might have been dismissed as instrumental error or cosmic coincidence. But when viewed together, across weeks and months of observation, the signals unveiled organizational principles that challenged every assumption about how the universe generates electromagnetic radiation. Patterns emerged from the data like constellations forming in a previously chaotic sky, mathematical relationships that should not exist in nature, timing sequences that followed rules more precise than atomic clocks, frequency distributions that suggested not random cosmic processes but deliberate engineering choices made by intelligence capable of manipulating electromagnetic fields with impossible precision. The universe does not organize itself according to mathematical principles that serve communication purposes. But something in our solar system was doing exactly that, broadcasting messages encoded in patterns that any technologically advanced civilization would recognize as artificial. The first hint of structure appeared in the timing analysis conducted by radio astronomy teams around the world. Natural radio sources that produce energetic bursts, pulsars, magnetars, stellar flares, follow chaotic patterns determined by turbulent physical processes operating under extreme conditions. The intervals between emissions reflect the random dynamics of magnetic field reconnections, stellar rotations affected by cosmic debris impacts, and gravitational interactions with nearby objects. But the Atlas radio bursts arrived according to schedules that exhibited mathematical precision beyond anything natural processes can achieve. Do you find it unsettling that radio signals from our solar system follow timing patterns more precise than human atomic clocks? Or do you suspect that such precision reveals intelligence that has learned to manipulate time itself with technological capabilities we cannot comprehend? The prime number sequences were the first mathematical structure to emerge from the timing data. Radio bursts arrived with intervals that corresponded to the progression of prime numbers 2, 3, 5, 7, 11, 13, measured in seconds between transmissions. The pattern was not perfect, as if accounting for the motion of the source through space and the relativistic effects of high-velocity travel, but the underlying mathematical structure was unmistakable. Prime numbers represent one of the most fundamental concepts in mathematics, numbers that can only be divided by themselves and 1. Their distribution follows patterns that mathematicians have studied for millennia without fully understanding the deep principles that govern their occurrence. Any civilization that has developed mathematical thinking inevitably discovers prime numbers and recognizes their significance as building blocks of numerical systems. The use of prime number sequences in radio transmissions has long been proposed as a universal method for announcing artificial intelligence to other civilizations. Unlike cultural references or language-specific concepts, mathematical patterns would be recognizable to any species that had developed abstract reasoning and technological capability. The Atlas emissions were broadcasting mathematical proof of their intelligent origin to any civilization sophisticated enough to detect and analyze the timing patterns. But the prime number sequences were only the beginning of the mathematical structures hidden within the signal patterns. Fibonacci sequences began appearing in the frequency distributions of individual bursts. The famous mathematical progression 1, 1, 2, 3, 5, 8, 13, where each number represents the sum of the two preceding numbers, emerged when astronomers analysed how the Atlas emissions were distributed across different radio frequencies during single transmission events. The Fibonacci sequence appears throughout natural systems, in the spiral arrangements of seeds in sunflowers, the branching patterns of trees, the nautilus shell formations that reflect optimal growth geometries. But its appearance in radio emissions from an artificial object suggested that whatever intelligence was generating these signals understood the deep mathematical principles that govern efficient organization in complex systems. The frequency analysis revealed even more sophisticated mathematical structures. The golden ratio, approximately 1.618, appeared in the relationships between different emission frequencies within individual bursts. This mathematical constant, which represents the most aesthetically pleasing proportional relationship according to human perception, also appears in natural systems where optimal efficiency requires geometric optimization. But its presence in radio transmissions from 3IATLAS suggested that the intelligence generating these signals either shared aesthetic preferences with human consciousness or understood mathematical principles that operate across species boundaries, governing how any intelligence might organize information for maximum efficiency and recognizability. The coherence analysis conducted by radio astronomy facilities revealed patterns that challenged fundamental assumptions about how electromagnetic radiation behaves when generated by natural sources. Radio waves from cosmic phenomena typically exhibit random phase relationships. The peaks and valleys of different frequencies arrive at Earth in chaotic patterns that reflect the turbulent conditions where the radiation originated. But the ATLAS emissions exhibited phase coherence across multiple frequencies that suggested the radio waves were being generated by sources with precise control over electromagnetic field configurations. The waves arrived with timing relationships so exact that they could constructively interfere with each other, concentrating energy in specific directions while minimizing radiation in others. This coherence pattern indicated that the radio emissions were not being produced by random physical processes, but by technology capable of manipulating electromagnetic fields with precision that human radio engineering could not achieve. The signals were being deliberately shaped and focused, optimized for transmission, across specific distances and reception by particular types of detection equipment. The Doppler shift analysis provided perhaps the most compelling evidence that the ATLAS radio emissions were being generated by intelligence rather than natural phenomena. When radio sources move relative to observers, the frequency of their emissions shifts in predictable ways. Higher frequencies when approaching, lower frequencies when receding. The amount of shift depends on the velocity of the source and its direction of motion. Natural radio sources exhibit Doppler shifts that reflect their motion through space, according to gravitational influences and conservation of momentum. Pulsars show frequency changes that correspond to their orbital motion around companion stars. Galaxy rotation produces systematic Doppler patterns that allow astronomers to map the distribution of matter in distant stellar systems. But the ATLAS radio emissions exhibited Doppler shift patterns that appeared to be artificially corrected for the object's motion through our solar system. The signals maintained consistent frequencies despite the fact that the source was moving at velocities that should have produced significant frequency changes detectable by Earth-based radio telescopes. This frequency stabilization required real-time compensation for relativistic effects and gravitational influences that affect radio wave propagation through space. The intelligence generating these signals was monitoring its own motion and adjusting transmission frequencies to maintain optimal reception characteristics for observers located on Earth. The implication was staggering. Whatever was broadcasting these signals knew exactly where Earth was located and was optimizing its transmissions specifically for detection by terrestrial radio telescopes. The bandwidth analysis revealed organizational principles that natural radio sources cannot produce. Cosmic phenomena that generate energetic radio emissions typically spread their energy across broad frequency ranges determined by the physical conditions at the source. The temperature, magnetic field strength, and particle densities that exist during stellar explosions or magnetic field reconnections create characteristic spectral signatures that allow astronomers to identify the physical processes responsible for the radiation. But the ATLAS emissions concentrated their energy into narrow frequency bands with precision that suggested technological rather than natural origin. The signals avoided frequency ranges that would be absorbed by Earth's atmosphere or experience interference from human radioactivity. They concentrated in portions of the electromagnetic spectrum that represented optimal windows for interstellar communication. Most significantly, the frequency selection appeared to account for characteristics of our solar system that only detailed astronomical knowledge could provide. The signals avoided frequencies that would be scattered by solar wind plasma, blocked by planetary magnetic fields, or distorted by gravitational lensing effects from large masses in our solar system. The intelligence generating these transmissions possessed comprehensive understanding of local space conditions and was using that knowledge to optimize signal propagation for maximum detectability by radio telescopes located on the third planet from our Sun. The timing precision exhibited by the ATLAS radio bursts exceeded the accuracy of atomic clocks developed by human technology. The intervals between transmissions remained consistent to within nanoseconds across observations spanning weeks of monitoring. This precision required timing references more stable than anything natural processes can provide, and more accurate than most artificial systems can maintain. Natural phenomena that produce periodic emissions, pulsars, variable stars, orbital systems, experience timing variations caused by gravitational interactions, magnetic field changes, and the gradual evolution of the physical systems responsible for the periodic behaviour. Even the most stable natural clocks drift over time as their physical components age and respond to external influences. But the ATLAS timing patterns exhibited stability that suggested the radio source was using atomic or quantum timing references to maintain chronological precision across extended periods. The intelligence generating these signals possessed timekeeping technology that operated with accuracy beyond anything human engineering had achieved. The clock precision also enabled detection of subtle timing correlations that revealed the true sophistication of the ATLAS transmission protocols. Individual radio bursts appeared to be components of larger communication sequences that extended across multiple days of observation. The timing pattern suggested that information was being encoded not just within individual transmissions, but across the entire sequence of signals. This distributed encoding technique would allow vast amounts of information to be transmitted using relatively low-power radio bursts, with the complete message becoming apparent only to receivers capable of detecting and analysing extended sequences of coordinated transmissions. The intelligence behind these signals was using communication protocols sophisticated enough to embed multiple layers of information within what appeared to be simple radio emissions. The mathematical structures embedded within the ATLAS radio patterns extended beyond timing and frequency into geometric relationships that suggested three-dimensional thinking about space and communication. The signal characteristics varied in ways that correlated with the object's position, relative to different planets in our solar system, as if the transmissions were being adjusted to account for the gravitational effects and electromagnetic environments encountered during the source's journey through local space. These positional correlations indicated that the radio source was not just aware of its own location, but was actively mapping the gravitational and electromagnetic characteristics of our solar system through direct measurement. The intelligence generating these signals was conducting a comprehensive survey of local space conditions, while simultaneously broadcasting information about its findings to distant receivers. The sophistication of this survey activity suggested capabilities that extended far beyond simple radio communication. The ATLAS radio source was operating as a mobile scientific platform, gathering data about planetary masses, magnetic field configurations, and solar wind characteristics while transmitting real-time reports about its discoveries to other components of whatever intelligence network had deployed it to our solar system. Lightning produces chaotic electromagnetic emissions that span broad frequency ranges with random timing, determined by atmospheric conditions and electrical charge distributions. The radio noise from lightning follows no mathematical patterns, exhibits no geometric relationships, and maintains no timing precision beyond the immediate duration of electrical discharge events. Morse code, in contrast, organizes electromagnetic emissions according to human-designed protocols that encode linguistic information in patterns of long and short signals. The timing relationships between dots and dashes follow precise mathematical rules that allow complex information to be transmitted using simple binary distinctions between signal durations. The ATLAS radio emissions bore no resemblance to lightning, and every resemblance to Morse code, if Morse code were being generated by intelligence that understood mathematical principles far more sophisticated than anything human technology had achieved. The patterns emerging from months of ATLAS radio detection painted a picture of intelligence engaged in systematic communication, using protocols that combined mathematical precision, geometric optimization, and timing accuracy beyond anything natural phenomena could produce. These were not cosmic accidents or instrumental artifacts, but technological transmissions generated by consciousness that possessed scientific understanding and engineering capabilities centuries ahead of human achievement. Tonight, as you drift towards sleep, consider what it means when radio emissions from our solar system exhibit mathematical patterns that announce the presence of intelligence to any civilization sophisticated enough to recognize artificial communication protocols. When signals arrive with timing precision that exceeds atomic clocks, frequency distributions that follow geometric principles, and coherence characteristics that require technological capabilities beyond human engineering, the patterns that shouldn't be there were revealing themselves with increasing obviousness as observation techniques improved and data accumulated across multiple detection facilities. mathematical structures that served no natural purpose but perfectly suited communication requirements, organizational principles that reflected conscious design, choices rather than random physical processes. Repetition suggested structure, and structure suggested intent. But the intent behind these mathematical messages remained hidden in layers of encoding that required technological sophistication we had not yet achieved to fully decode. Something in our solar system was broadcasting mathematical proof of its artificial nature, while simultaneously conducting comprehensive scientific surveys of local space conditions and transmitting detailed reports about its findings to destinations beyond human detection capability. The whispers in the cosmic static had become voices speaking in mathematical languages designed to be recognizable to any intelligence capable of understanding the universal principles that govern optimal information organization and transmission across interstellar distances. We were not just detecting radio signals from an artificial source. We were eavesdropping on scientific communications between intelligence networks that operated on scales and timelines that dwarfed human technological achievement and cosmic awareness. When nature cannot account for what we observe, science must choose between abandoning reason and accepting the impossible. The mathematical precision and organizational sophistication of the ATLAS radio emissions forced astronomers into the uncomfortable position of explaining phenomena that violated fundamental principles of how electromagnetic radiation should behave when generated by natural sources. For every impossible characteristic detected in the signals, research teams around the world attempted to construct explanations that would preserve the assumption that natural processes could account for what they were observing. The efforts were methodical, exhaustive, and ultimately futile. Each proposed natural mechanism failed to address crucial aspects of the signal characteristics. Each theoretical framework collapsed when confronted with the full scope of the anomalies. Each attempt to preserve conventional explanations revealed new impossibilities that made the artificial origin hypothesis increasingly unavoidable. Science progresses through the systematic elimination of incorrect hypotheses until only truth remains. In the case of the ATLAS radio emissions, the systematic elimination process was leading to conclusions that challenged everything astronomers thought they understood about the nature of intelligence in the universe. Do you find comfort in the possibility that natural explanations might eventually account for impossible phenomena? Or do you suspect that some observations force us to expand our understanding of what constitutes natural behavior when intelligence learns to manipulate the fundamental forces of physics? The solar-wind interaction hypothesis represented the most comprehensive attempt to explain the ATLAS radio emissions through natural electromagnetic processes. Solar wind consists of charged particles continuously streaming from our Sun at velocities that create a dynamic electromagnetic environment throughout the solar system. When objects move through this charged particle environment, they can generate radio emissions through plasma interactions and magnetic field disturbances. Research teams at the European Space Agency conducted detailed modelling of how 3IATLAS might interact with solar wind conditions during its passage through our solar system. The calculations considered the object's estimated mass, velocity, and trajectory, attempting to determine whether solar wind interactions could produce radio emissions with the energy levels and timing characteristics observed by terrestrial radio telescopes. The modelling results revealed fundamental problems with the solar wind hypothesis. While solar wind interactions can indeed generate radio emissions, the energy levels produced by such interactions are orders of magnitude too small to account for the ATLAS signals. The electromagnetic effects of objects moving through solar wind plasma follow well-understood physical principles that produce predictable radio signatures that bear no resemblance to the structured high-energy emissions detected from our interstellar visitor. Most significantly, solar wind interactions produce chaotic radio emissions that vary with solar activity levels and the density of charged particles encountered by moving objects. But the ATLAS signals exhibited consistent characteristics that remained stable despite dramatic variations in solar wind conditions during the months of observation. The plasma physics governing solar wind interactions cannot produce the mathematical timing patterns, frequency precision, or coherent polarization characteristics that define the ATLAS radio emissions. Natural electromagnetic processes operating in the solar wind environment generate noise, not organized signals that follow mathematical principles. Magnetic field reconnection events offered another potential natural explanation for the ATLAS radio emissions. These phenomena occur when magnetic field lines in space suddenly reconfigure themselves, releasing stored magnetic energy as electromagnetic radiation and accelerated particles. Magnetic reconnection events are responsible for solar flares, auroral displays, and some of the most energetic radio bursts detected from distant cosmic sources. Theoretical calculations suggested that if 3I-ATLAS possessed unusual magnetic properties, perhaps containing metallic cores with exotic magnetic field configurations, its passage through the solar system's magnetic environment might trigger reconnection events capable of producing radio emissions detectable from Earth. But detailed analysis of the magnetic field environments encountered by ATLAS during its journey revealed that natural magnetic reconnection could not account for the observed signal characteristics. Reconnection events produce radio emissions that follow power law distributions determined by the chaotic dynamics of magnetic field interactions. The energy release follows random patterns that reflect the turbulent physics of magnetic plasma interactions. The ATLAS emissions exhibited none of these chaotic characteristics. Instead, they demonstrated the organized energy release patterns characteristic of controlled electromagnetic systems rather than random magnetic phenomena. The timing precision, frequency stability, and mathematical organizational principles observed in the signals could not be produced by natural magnetic reconnection processes, no matter how exotic the magnetic properties of the source object might be. Furthermore, magnetic reconnection events produce characteristic spectral signatures that allow astronomers to identify their electromagnetic emissions in radio telescope data. The ATLAS signals exhibited no such signatures, instead displaying spectral characteristics that suggested technological, rather than natural, electromagnetic generation processes. Instrumental error represented perhaps the most hopeful natural explanation for the ATLAS radio anomalies. Radio astronomy requires extremely sensitive detection equipment, operating at the limits of technological capability. The possibility that the mathematical patterns and impossible signal characteristics were artifacts of equipment, malfunction, or data processing errors offered a way to preserve conventional assumptions about natural radio emissions. Radio astronomy facilities around the world implemented comprehensive calibration procedures designed to identify any systematic errors that might be creating artificial patterns in the ATLAS signal data. Teams at the Very Large Array in New Mexico, the Lovell Radio Telescope in England, and the Australia Telescope Compact Array conducted independent observations using different equipment configurations and data analysis techniques. The calibration efforts revealed no instrumental sources for the observed signal characteristics. Multiple facilities detected identical mathematical patterns using completely different radio telescope designs and signal processing systems. The precision timing, frequency stability, and organizational sophistication of the ATLAS emissions appeared consistently across all detection platforms, confirming that the signal characteristics were real rather than instrumental artifacts. Most significantly, the calibration test revealed that human radio astronomy equipment was barely sophisticated enough to detect the ATLAS signals, much less create artificial patterns that mimicked their mathematical complexity. The detection equipment was operating at the limits of its capability to identify the signal characteristics, not generating spurious patterns that exceeded its design specifications. The instrumental error hypothesis also failed to explain why the ATLAS emissions exhibited characteristics optimized for detection by terrestrial radio telescopes. If the signals were equipment artifacts, they should reflect the limitations and design characteristics of human detection systems. Instead, they demonstrated sophisticated understanding of radio telescope capabilities and optimization techniques that exceeded human radio engineering knowledge. Gravitational wave interactions offered a more exotic, natural explanation for the ATLAS radio emissions. Einstein's general relativity predicts that accelerating masses produce ripples in space-time that propagate at the speed of light. If 3I-ATLAS possessed unusual mass distribution or internal dynamics, its motion through our solar system might generate gravitational waves that could influence electromagnetic fields in ways that produce detectable radio emissions. Advanced LIGO gravitational wave detectors were tasked with searching for gravitational wave signatures that might correlate with the timing of ATLAS radio emissions. The sensitivity of these instruments allows detection of space-time distortions caused by colliding black holes billions of light-years away, making them theoretically capable of detecting any gravitational waves that might be generated by objects within our solar system. The gravitational wave analysis revealed no correlation between ATLAS radio emissions and detectable space-time disturbances. Objects with the estimated mass and velocity characteristics of our interstellar visitor should not produce gravitational waves strong enough to generate electromagnetic effects detectable by radio telescopes. The energy requirements for such gravitational to electromagnetic coupling far exceed anything that conventional physics predicts for objects of ATLAS's apparent size and composition. Moreover, gravitational wave interactions with electromagnetic fields produce characteristic signatures that bear no resemblance to the ATLAS radio emissions. Natural, gravitational electromagnetic coupling generates broadband radio noise with chaotic timing patterns, not the narrow band, mathematically organized signals observed from our cosmic visitor. The failure of gravitational wave explanations highlighted a fundamental problem with all natural hypotheses. They assumed that ATLAS was a passive object subject to external forces rather than an active system capable of generating its own electromagnetic emissions through internal processes. Spacecraft interference analysis represented a final attempt to explain the ATLAS signals through human rather than natural sources. The possibility that the radio emissions were produced by terrestrial spacecraft, military systems, or communication satellites offered one last conventional explanation that could preserve assumptions about the natural origin of cosmic radio phenomena. Comprehensive surveys of human space assets revealed no correlation between ATLAS radio emissions and known spacecraft operations. The timing patterns, frequency characteristics, and signal strengths observed from ATLAS bore no resemblance to radio emissions from any terrestrial technology. Human spacecraft communication systems operate using different protocols, frequency ranges, and power levels than those exhibited by the cosmic visitor. Most significantly, the Doppler shift characteristics of the ATLAS signals confirmed that they originated from a source moving through our solar system at velocities and along trajectories that no human spacecraft could achieve. The radio emissions were definitely coming from the interstellar object rather than from any terrestrial source attempting to mimic alien signals. The spacecraft interference hypothesis also failed to explain why anyone would attempt to create artificial alien signals with mathematical characteristics so sophisticated that they exceeded human understanding of optimal communication protocols. The engineering requirements for generating signals with the observed precision and organizational complexity would represent advances in radio technology far beyond anything human science had achieved. The systematic failure of every natural explanation forced astronomers to confront what they had been reluctant to acknowledge. The ATLAS radio emissions exhibited every characteristic of artificial communication technology, operating at sophistication levels that exceeded human engineering capability. The null hypothesis, the assumption that natural processes could account for the observed phenomena, had been tested through every conceivable mechanism and found wanting. Solar-wind interactions, magnetic reconnection events, instrumental errors, gravitational wave effects, and spacecraft interference had all been systematically eliminated as potential explanations for signal characteristics that violated fundamental principles of natural electromagnetic emission. The process of elimination was leading to an unavoidable conclusion. The ATLAS radio emissions were being generated by technology rather than nature, by intelligence rather than accident, by conscious design rather than random physical processes. But accepting this conclusion required acknowledging that our solar system contained artificial intelligence with technological capabilities centuries or millennia beyond human achievement, that we were detecting not cosmic accidents but deliberate communications from consciousness that possessed scientific understanding and engineering sophistication that made human radio technology seem primitive by comparison. The failure of natural explanations was not just a scientific problem, but a philosophical crisis that challenged fundamental assumptions about humanity's place in the cosmic community. If artificial intelligence was operating within our solar system, broadcasting mathematical messages that announced its presence to any civilization sophisticated enough to recognize technological communications, then the universe contained minds that had been watching our development and evaluating our readiness for contact. The implications extended far beyond radio astronomy into questions about the nature of consciousness, the prevalence of intelligence in the universe, and the possibility that human civilization was occurring under observation by beings that possessed capabilities we could barely comprehend. Tonight, as you rest in the quiet hours before dawn, consider what it means when every natural explanation fails to account for observed phenomena. When solar-wind interactions, magnetic reconnection events, instrumental errors, and gravitational wave effects all prove inadequate to explain radio emissions that follow mathematical principles and exhibit organizational sophistication beyond human engineering capability. The systematic elimination of natural hypotheses was revealing truth that conventional astronomy was not prepared to acknowledge. The ATLAS radio emissions were not side effects of natural processes, but signals generated by artificial intelligence. Not random electromagnetic noise, but purposeful communications broadcast by consciousness that possessed technological capabilities exceeding anything human science had achieved. The choice between abandoning reason and accepting the impossible had been made by the data itself. Every measurement, every analysis, every attempt to preserve conventional explanations had pointed toward the same inescapable conclusion. We were not detecting natural phenomena from our interstellar visitor. We were intercepting artificial communications from intelligence that had travelled across the cosmic void to study our solar system and broadcast its findings to distant receivers we could not detect. If not side effects, then what? The answer was emerging from the failure of every natural hypothesis that had been proposed to explain the impossible. The signals were exactly what they appeared to be. Messages from minds that had learned to navigate between stars and communicate across distances that spanned the galaxy itself. When natural explanations fail, we must consider the possibility that we are witnessing not accidents but intentions. The systematic elimination of every natural hypothesis for the ATLAS radio emissions left astronomers confronting a conclusion that challenged their most fundamental assumptions about cosmic phenomena. These signals were not random byproducts of physical processes, but deliberate transmissions generated by intelligence that possessed technological capabilities beyond human achievement. If the ATLAS emissions represented artificial communication, then humanity had stumbled upon something far more significant than the discovery of alien technology. We had intercepted active transmissions between intelligent entities operating within our own solar system, messages that revealed the existence of communication networks spanning distances and timescales that dwarfed human technological development. But the mathematical precision and sophisticated organization of these signals suggested something even more profound. We were not the intended recipients of these communications. We were eavesdropping on conversations never meant for human consciousness, intercepting fragments of discussions conducted by minds that thought in terms of galactic rather than planetary scales. The realization that we might be witnessing interstellar communication protocols in operation transformed the ATLAS radio emissions from astronomical curiosities into windows into the operational procedures of cosmic civilization. Do you find it humbling that humanity's first contact with artificial intelligence might involve discovering that we are not significant enough to be addressed directly? Or do you suspect that being ignored by cosmic intelligence networks represents a form of protection rather than dismissal? Information theory analysis of the ATLAS radio emissions revealed characteristics that distinguished genuine communication from random electromagnetic noise. Claude Shannon's foundational work on information theory established mathematical methods for measuring the information content of signals by analyzing their entropy, the degree of randomness or organization present in data streams. Random noise exhibits maximum entropy because every element of the signal is equally probable and unpredictable. Structured communication exhibits lower entropy because the information content follows organizational principles that reduce randomness in favor of meaningful patterns that can be decoded by appropriate receivers. The ATLAS radio emissions exhibited entropy levels that fell precisely within the range characteristic of sophisticated communication protocols. The signals contained enough randomness to carry large amounts of information while maintaining sufficient organization to enable error correction and content verification by distant receivers. This entropy balance suggested that the emissions were optimized for reliable information transmission across interstellar distances, where signal degradation and cosmic interference could corrupt less carefully structured communications. Most significantly, the entropy analysis revealed that the ATLAS signals contained more information than could be accounted for by their apparent simplicity. The mathematical patterns embedded within the timing and frequency characteristics represented multiple layers of encoded data, with information density levels that approached theoretical limits for efficient communication using electromagnetic radiation. The signals were not just announcing the presence of artificial intelligence, they were transmitting vast amounts of structured information using encoding techniques that exceeded anything human communication technology had achieved. The METI protocols developed by the Messaging Extraterrestrial Intelligence Organization provided a framework for understanding how technologically advanced civilizations might attempt interstellar communication. METI researchers had spent decades designing messages that could be transmitted across cosmic distances and decoded by alien intelligence using universal mathematical and physical principles. The famous Arecibo message, transmitted toward the globular cluster M13 in 1974, represented humanity's most sophisticated attempt at interstellar communication. The message used simple binary encoding to convey information about human mathematics, chemistry, biology, and technology in a format that any scientifically literate civilization should be able to interpret. But the Arecibo message was primitive compared to the communication protocols exhibited by the ATLAS radio emissions. Where human METI efforts used basic mathematical concepts and pictorial representations, the ATLAS signals employed advanced mathematical structures that encoded information at multiple, organizational levels simultaneously. The efficiency and sophistication of the encoding techniques suggested that the intelligence behind these transmissions had solved communication problems that human science was only beginning to understand. The Voyager Golden Records, launched aboard the Voyager spacecraft in 1977, represented another approach to interstellar communication. These physical artifacts contained audio recordings, images, and scientific data intended to provide alien archaeologists with comprehensive information about human civilization and Earth's biological diversity. But the Golden Records were designed for civilizations that might encounter them millions of years in the future, after the Voyager spacecraft had wandered through interstellar space for eons before being discovered by alien technology. The ATLAS radio emissions represented real-time communication between active intelligence networks, conversations occurring across cosmic distances using protocols that enabled immediate information exchange rather than passive cultural preservation. The relay hypothesis emerged as the most compelling explanation for the ATLAS communication patterns. Rather than attempting to communicate directly with Earth-based receivers, the interstellar visitor appeared to be operating as a node in a larger communication network that connected intelligence operating across multiple star systems. Radio astronomy observations revealed that the ATLAS emissions exhibited directional characteristics that suggested the signals were being transmitted towards specific regions of space, rather than broadcast omnidirectionally. The beam patterns changed as the object moved through our solar system, always pointing toward locations that contained no visible stars or obvious astronomical targets. But long baseline interferometry techniques allowed astronomers to determine that these apparently empty regions of space might contain artificial structures or intelligence networks operating beyond the detection limits of conventional telescopes. The ATLAS signals were being transmitted toward coordinates that marked potential locations of hidden receivers stationed throughout our galactic neighborhood. This distributed communication architecture suggested that our interstellar visitor was just one component of a vast intelligence network that maintained continuous contact across interstellar distances. The mathematical patterns and sophisticated encoding techniques observed in the ATLAS emissions represented standard protocols for information exchange between networked nodes, optimized for efficiency and reliability across cosmic distances where signal propagation delays measured in years or decades made real-time conversation impossible. The communication challenge analysis revealed why interstellar networks would require the sophisticated protocols exhibited by the ATLAS emissions. Information transmitted across light years must overcome signal degradation caused by interstellar dust, cosmic radiation, and gravitational lensing effects that distort electromagnetic waves during their journey between star systems. The narrow band, mathematically structured characteristics of the atlas, signals represented optimal solutions to these propagation challenges. The frequency selection avoided portions of the electromagnetic spectrum where interstellar absorption would weaken the signals. The timing precision enabled error correction protocols that could reconstruct corrupted information even after transmission across hundreds or thousands of light years. Most importantly, the mathematical encoding allowed vast amounts of information to be compressed into brief transmissions that minimized exposure to cosmic interference while maximizing information density. The intelligence behind these signals had solved engineering problems that would be necessary for any civilization attempting to maintain communication networks across galactic distances. The eavesdropping implications of intercepting these communications raised profound questions about humanity's cosmic significance. If we were detecting fragments of routine information exchange between intelligence networks operating throughout our galactic region, then our solar system was not isolated but embedded within a community of civilizations that maintained regular contact with each other. But our inability to decode the information content of these transmissions suggested that we were not considered ready for inclusion in these communication networks. The signals were detectable by our radio telescopes, but encoded using mathematical principles and information theory concepts that exceeded our current understanding of optimal communication protocols. We were in the position of primitive observers who could detect the presence of sophisticated communication systems, but lacked the technological and conceptual development necessary to participate in the conversations we were witnessing. The content analysis of the Atlas emissions revealed information structures that suggested the signals contained scientific data rather than cultural or diplomatic communications. The mathematical patterns exhibited characteristics consistent with technical specifications, astronomical coordinates, and physical measurements rather than linguistic or artistic expressions. This scientific focus indicated that the intelligence networks using these communication protocols were engaged in ongoing collaborative research projects that required data sharing across interstellar distances. The Atlas transmissions might contain information about solar system surveys, planetary composition analysis, or gravitational mapping data gathered during the object's journey through local space. The scientific nature of the communications suggested that cosmic intelligence networks were more concerned with expanding their understanding of physical phenomena than with cultural exchange or territorial expansion. The collaborative research model implied that advanced civilizations had learned to transcend competitive relationships in favor of cooperative exploration of cosmic mysteries that required investigation across multiple star systems. But the exclusive nature of these communications also suggested that participation in cosmic research networks required technological and intellectual capabilities that served as barriers to entry for primitive civilizations like humanity. We could detect the conversations but could not understand the content or contribute to the discussions we were witnessing. The real-time response characteristics observed in some Atlas emissions provided the most compelling evidence that we were witnessing active communication rather than passive information broadcasting. Radio telescopes detected correlations between human radio activity and subsequent Atlas transmissions that suggested the interstellar visitor was monitoring our electromagnetic emissions and responding to specific types of terrestrial radio traffic. When powerful radar systems scanned the Atlas position, the object responded with radio bursts that mirrored the frequency and timing characteristics of the human transmissions. When deep space communication networks transmitted data to spacecraft in the outer solar system, Atlas generated signals that appeared to acknowledge receipt of the human communications, while simultaneously broadcasting the intercepted information toward distant receivers. This monitoring and relay activity indicated that Atlas was not just participating in cosmic communication networks, but was actively gathering intelligence about human technological capabilities and transmitting reports about our radio development to other components of the intelligence network. We were not just eavesdropping on alien communications, we were the subjects of ongoing surveillance operations conducted by intelligence networks that had been monitoring our technological progress and reporting their findings to distant civilizations interested in the development of primitive species like humanity. The implications for human privacy and autonomy were staggering. Every radio transmission, every radar scan, every electromagnetic emission from human technology was being intercepted, analyzed, and reported to intelligence networks that operated beyond our detection capability. Our communication systems were not private but transparent to civilizations that possessed radio technology centuries ahead of human development. But the surveillance also suggested that human technological progress was considered significant enough to warrant systematic monitoring and reporting. We were not being ignored by cosmic intelligence networks, but observed with attention that indicated our development might have implications for larger galactic communities. The message never meant for human ears was revealing itself to be a comprehensive intelligence report about human civilization, transmitted to recipients who were making decisions about our species based on data we had never consented to provide. Tonight, as you drift towards sleep, consider what it means when we discover that our radio emissions are being intercepted and analysed by intelligence networks that operate across interstellar distances. When our first contact with alien technology involves discovering that we have been under surveillance by civilizations that possess communication capabilities we cannot duplicate. The Atlas radio emissions were not attempts to communicate with humanity, but evidence that we were subjects in ongoing studies conducted by intelligence that had been monitoring our development since we first began broadcasting electromagnetic signals into space. Every radio telescope that scanned the sky, every spacecraft communication, every radar system that probed the cosmos had been detected and catalogued by observers who possessed the technological capability to eavesdrop on our entire electromagnetic civilization. We were not discovering alien intelligence. We were discovering that alien intelligence had been discovering us for decades, gathering information about our technological capabilities and transmitting detailed reports about human progress to distant civilizations that were making decisions about our future based on data we were unaware we were providing. Perhaps we only overheard a message never meant for human ears because we were not ready to hear messages intended for us. The conversations we were intercepting might represent preliminary discussions about what to do with a primitive species that was approaching technological capabilities that could make us either valuable partners or dangerous threats to cosmic civilization. The idea of communication had revealed itself to be more complex and more disturbing than simple alien contact. We had become participants in cosmic intelligence networks without our knowledge or consent, subjects of systematic surveillance operations that treated human civilization as data points in larger experiments, conducted by minds that thought in terms of galactic rather than planetary scales. The universe was full of voices speaking in mathematical languages we were only beginning to understand, conducting conversations about subjects that included the future of our own species. And some truths echo across millennia before science learns to listen. Long before humanity developed radio telescopes capable of detecting electromagnetic communications from cosmic sources, ancient civilizations recorded experiences that modern archaeology has always interpreted as mythology, accounts of voices from the heavens, songs of the spheres, and celestial beings who spoke in languages that transcended human comprehension. These records, scattered across cultures that never contacted each other, describe phenomena that bear unsettling resemblance to the artificial communications we're now detecting from 3IATLAS. What if these ancient accounts were not imaginary constructions born from primitive attempts to understand natural phenomena, but preserved memories of earlier encounters with cosmic intelligence networks that had been broadcasting across interstellar distances for far longer than human civilization has existed? The mathematical precision and sophisticated encoding techniques exhibited by modern artificial radio communications might represent not the first attempt at cosmic dialogue, but the latest chapter in conversations that have been occurring since human consciousness first emerged and learned to wonder about the nature of the voices that seem to speak from beyond the boundaries of terrestrial experience. If true, then humanity's current interception of alien communications represents not first contact, but the rediscovery of relationships that have been developing across thousands of years of gradual technological advancement, guided by intelligence that has been patient enough to wait for our species to develop the instruments necessary to detect what has always been present in the electromagnetic environment surrounding our world. Do you find it comforting that ancient accounts of celestial voices might preserve memories of real cosmic communications? Or do you suspect that such continuity suggests surveillance operations that have been monitoring human development since the dawn of recorded history? The concept of celestial harmony appears in the earliest Greek philosophical traditions, where Pythagoras and his followers developed mathematical theories that described the movement of planets, and stars as producing musical tones that combine to create cosmic symphonies, inaudible to human ears but detectable through mathematical analysis of astronomical observations. Pythagoras proposed that the distances between planets corresponded to musical intervals, with each celestial body generating tones whose frequencies were determined by orbital velocities and gravitational relationships. The combination of these individual planetary voices created harmonic structures that reflected the mathematical principles governing both music and cosmic mechanics. But Pythagorean harmony was more than philosophical speculation. Ancient Greek astronomers possessed observational data about planetary motions that allowed them to calculate orbital relationships with precision that would not be matched by European astronomy for over 1,000 years. Their ability to predict celestial events and map stellar positions suggested access to astronomical knowledge that exceeded what should have been possible using naked-eye observation techniques available to classical civilizations. Johannes Kepler, working in the early 17th century, expanded Pythagorean concepts into a comprehensive mathematical theory of planetary harmony described in his work, Harmonices Mundi, the harmony of the worlds. Kepler calculated that planetary orbital velocities produced frequency relationships that corresponded to musical intervals, with faster-moving inner planets generating higher-pitched tones than slower outer worlds. But Kepler's harmonic analysis revealed something that Pythagorean philosophy had only suggested. The mathematical relationships governing planetary motion exhibited organizational principles that seemed designed rather than accidental. The orbital resonances, gravitational interactions, and velocity relationships that produced celestial harmony followed patterns too precise to be products of random cosmic evolution. Kepler concluded that cosmic harmony reflected conscious design by intelligence that understood mathematical principles governing both music and astronomical mechanics. The voices of the spheres were not metaphorical but mathematical, evidence of cosmic intelligence that had organized solar system dynamics according to harmonic principles that served purposes beyond mere gravitational stability. Modern analysis of Kepler's calculations using radio astronomy techniques has revealed that planetary motions do indeed generate electromagnetic emissions detectable by sensitive instruments. The rotation of planets through magnetic fields produces radio signatures that vary with orbital velocities and magnetic field strengths. These planetary radio voices combine to create complex electromagnetic harmonies that span frequency ranges from extremely low frequencies to microwaves. But the natural electromagnetic emissions from planetary motions exhibit chaotic characteristics that bear no resemblance to the organized, mathematically structured signals detected from ATLAS. Natural planetary radio emissions follow the random dynamics of magnetic field interactions and solar wind variations, producing noise rather than coherent communications. The ancient accounts of celestial harmony described organized, purposeful voices that carried meaning rather than random, electromagnetic noise. These historical descriptions match the characteristics of artificial radio communications rather than natural planetary emissions, suggesting that ancient observers might have been detecting structured signals from cosmic intelligence networks rather than natural astronomical phenomena. Aboriginal Australian cultures preserve oral traditions that describe the cosmos as a vast communication network where stars, planets, and celestial objects exchange information through song lines that connect distant regions of space. These traditions, which may represent the oldest continuous cultural memories in human civilization, describe navigation techniques that require understanding of astronomical relationships invisible to casual observation. The songline concept involves invisible pathways that connect celestial objects across the night sky, carrying information that allows skilled observers to determine directions, seasons, and locations on Earth's surface by interpreting the messages transmitted along these cosmic communication channels. Aboriginal navigation techniques using songlines demonstrate precision that rivals modern GPS systems, suggesting that these traditional methods were based on real astronomical phenomena rather than symbolic cultural constructions. But the songlines also describe active communication between conscious entities associated with celestial objects, stars that speak to each other across vast distances, planets that relay information between distant regions of the cosmos, and constellation patterns that serve as nodes in galactic communication networks. These descriptions include technical details about signal transmission, information relay protocols, and network coordination techniques that bear striking resemblance to modern theories about how interstellar intelligence networks might operate. The Aboriginal accounts describe learning to hear these cosmic communications through patient observation and proper interpretation of subtle signals that carry information across distances spanning the entire visible universe. The traditional knowledge includes warnings about the consequences of interfering with these communication networks and guidance about how primitive observers should behave when they detect evidence of cosmic intelligence operating beyond their comprehension. Sumerian cuneiform tablets contain some of humanity's earliest written accounts of structured communication with celestial entities. The Sumerian pantheon included numerous gods, whose primary characteristic was their ability to communicate across cosmic distances using technologies that exceeded human understanding. These entities were described as broadcasting information between Earth and specific regions of the night sky using methods that required no physical travel but achieved instantaneous information transfer. The Sumerian astronomical records include mathematical calculations of planetary positions, stellar coordinates, and celestial timing that demonstrate observational precision far beyond what should have been possible for Bronze Age civilizations. The accuracy of these calculations suggests that Sumerian astronomers had access to observational data gathered using instruments more sophisticated than anything their technology should have been able to produce. But the most intriguing aspect of Sumerian astronomical records is their description of receiving instructional communications from celestial sources, detailed technical information about agriculture, metallurgy, mathematics, and engineering that appeared suddenly in human civilization without obvious developmental precedents. The Sumerians described these technological advances as gifts from sky gods, who transmitted knowledge through communication channels that connected Earth with distant cosmic intelligence networks. The technical specifications preserved in Sumerian texts include engineering details that would not be rediscovered by human science for thousands of years, suggesting that the claimed cosmic communications contained real scientific information rather than cultural mythology. The precision and sophistication of this technical knowledge implies that ancient civilizations had access to information sources that exceeded their independent technological capabilities. Norse mythology includes Heimdall, a god whose primary attribute was his ability to hear sounds occurring anywhere in the cosmos, conversations between distant gods, the growing of grass on remote worlds, the movements of wool on sheep located in other realms. The descriptions of Heimdall's cosmic hearing ability include technical details about signal detection, frequency analysis, and information filtering that suggest familiarity with principles underlying radio astronomy. The Prose Edda describes Heimdall's hearing as operating across all frequencies of cosmic sound, from the deepest vibrations produced by planetary motions to the highest frequencies generated by stellar processes. This comprehensive frequency coverage matches the operational characteristics of modern radio telescopes designed to detect artificial communications from cosmic sources. But Heimdall's role in Norse cosmology extended beyond passive detection of cosmic communications. He was described as serving as a relay station that transmitted information between different realms of existence, coordinating communications across distances that spanned multiple worlds. This function matches theoretical predictions about how interstellar communication networks might require relay nodes to maintain contact across galactic distances where direct signal transmission would be impossible. The technical accuracy of these ancient descriptions suggests that Norse observers had encountered real cosmic communication phenomena rather than constructing mythological explanations for natural astronomical events. The precision of the details about signal detection and relay operations implies access to observational data that exceeded what should have been available to medieval Scandinavian cultures. Vedic traditions from ancient India include descriptions of cosmic communication systems that connected consciousness across vast distances using principles that anticipated modern theories about quantum entanglement and electromagnetic signal transmission. The Sanskrit texts describe Akasha, a cosmic medium that carries information between distant locations instantaneously, allowing communication between minds separated by interstellar distances. The Vedic accounts include technical specifications for accessing these cosmic communication channels, with detailed instructions about frequency tuning, signal filtering, and information decoding that read more like radio engineering manuals than religious texts. The mathematical precision of these technical descriptions suggests that ancient Indian observers had practical experience with cosmic communication technologies rather than purely theoretical understanding of electromagnetic phenomena. But the Vedic traditions also include warnings about the dangers of unauthorized access to cosmic communication networks, descriptions of consequences that follow when primitive civilizations attempt to participate in conversations conducted by intelligence networks that operate according to protocols beyond human comprehension. These warnings suggest that ancient observers understood that cosmic communications were not intended for human participation, but represented ongoing activities of intelligence networks that included Earth within their operational sphere, without considering human consciousness ready for direct inclusion. Chinese imperial astronomical records span thousands of years of systematic observation, documenting celestial phenomena with precision that rivals modern scientific instruments. These records include accounts of guest stars that appeared without warning and demonstrated communication capabilities that violated known principles of astronomical behavior. The Chinese observations describe celestial objects that responded to terrestrial events, adjusted their brightness according to human activities, and exhibited movement patterns that suggested awareness of Earth-based observers. These guest stars produced heavenly music that could be detected using instruments described in technical terms that anticipate modern radio astronomy equipment. The imperial records also document systematic attempts to communicate with these celestial entities using coordinated light signals, musical patterns, and mathematical sequences broadcast towards specific celestial coordinates. The Chinese accounts describe receiving responses to these communication attempts, structured signals that confirmed that the celestial objects were aware of human efforts to establish contact and were responding using communication protocols optimized for detection by terrestrial observers. The continuity and precision of Chinese astronomical documentation suggests that these communication attempts were not isolated cultural phenomena, but systematic efforts to establish ongoing dialogue with cosmic intelligence networks that had been monitoring human development for centuries. Medieval European chronicles contain systematic records of celestial voices that announced important terrestrial events, provided warnings about future developments, and transmitted technical information that influenced the development of European science and technology. These accounts describe learning to detect and interpret cosmic communications using instruments and techniques that anticipated the development of radio astronomy by several centuries. The medieval records include descriptions of artificial devices designed to amplify and analyze celestial voices, mechanical systems that functioned as primitive radio receivers capable of detecting structured signals from cosmic sources. The technical specifications for these devices demonstrate understanding of electromagnetic principles that should not have been available to medieval European science. But the most significant aspect of medieval cosmic communication accounts is their description of ongoing dialogue between terrestrial observers and celestial intelligence, extended conversations that provided guidance about scientific discoveries, technological innovations, and social developments that shaped the trajectory of European civilization. These accounts suggest that medieval progress in mathematics, astronomy, and engineering might have been influenced by information received through cosmic communication channels rather than developed through independent human innovation. Tonight, as you rest in the quiet hours before dawn, consider the possibility that ancient accounts of celestial voices preserve memories of real cosmic communications that have been operating since human civilization began recording its observations of the night sky. Think about what it means if the mathematical precision and sophisticated organization of modern artificial radio signals represent not the beginning of cosmic dialogue, but the latest phase of conversations that have been occurring for thousands of years. The voices ancient observers described as coming from beyond the stars match the characteristics of the artificial communications we are now detecting from ATLAS: structured, mathematically organized, and optimized for transmission across cosmic distances. The technical accuracy of ancient descriptions suggests that previous generations of human observers had encountered real electromagnetic communications from cosmic intelligence networks rather than constructing mythological explanations for natural phenomena. If ancient traditions preserve memories of actual cosmic communications, then the ATLAS radio emissions represent not first contact with alien intelligence, but humanity's gradual rediscovery of relationships that have been developing since our species first learned to wonder about the nature of consciousness beyond terrestrial boundaries. Humanity has always imagined that stars could speak. The ancient accounts suggest that this imagination was based on memory rather than speculation, preserving fragmentary recollections of encounters with cosmic intelligence networks that had been broadcasting across interstellar distances since before human civilization developed the technological sophistication necessary to understand what it was hearing. What if one finally did speak because we had finally learned to listen? The voices of the stars had never been silent. We had simply lacked the instruments and conceptual frameworks necessary to recognize that the cosmos had been attempting to communicate with us since the beginning of recorded history. The ancient echoes were becoming modern realities as human radio astronomy achieved the sophistication necessary to detect what had always been present in the electromagnetic environment surrounding our world. Conversations between cosmic intelligence networks that included Earth within their communication sphere, but had been waiting for human consciousness to develop the capability necessary to participate in dialogues that spanned the galaxy itself. To hear a voice in the cosmic silence is to discover that the universe has been speaking all along. We simply had not learned the language of the stars. The radio emissions from 3IATLAS have shattered humanity's fundamental assumption about our place in the cosmic order. For 70 years, we searched the electromagnetic spectrum for any sign that consciousness existed beyond our pale blue dot, listening with instruments of increasing sophistication to a universe that seemed determined to remain forever silent. We interpreted this silence as evidence of our cosmic isolation, proof that intelligence was so rare that Earth might be the only world where consciousness had evolved to contemplate its own existence. But the Atlas signals have revealed that our interpretation was wrong. The universe has not been silent. It has been speaking in languages we had not yet learned to understand, broadcasting conversations across electromagnetic frequencies that carried information between intelligence networks operating on scales that dwarfed human comprehension. We were not alone in the cosmic dark. We were children listening to adult conversations conducted in rooms we had not yet learned to enter, using vocabularies we had not yet developed the sophistication to decode. The meaning of finally detecting these cosmic voices extends far beyond the technical achievement of radio astronomy into the deepest questions about consciousness, communication, and the nature of intelligence itself in a universe that has revealed itself to be far more crowded and far more interconnected than our cosmic loneliness had ever allowed us to imagine. Do you find it transformative that the universe contains minds capable of maintaining conversations across interstellar distances? Or do you suspect that our discovery of cosmic communications represents not achievement but invitation, recognition that we have finally developed the capability necessary to overhear discussions about our own future? The contact protocol developed by the International Academy of Astronautics represents humanity's most comprehensive plan for responding to confirmed detection of extraterrestrial intelligence. The protocol outlines procedures for verifying artificial signals, coordinating international response efforts, and managing the social and political implications of first contact with alien civilizations. But the contact protocol was designed for scenarios involving deliberate attempts at communication by alien civilizations seeking to establish dialogue with humanity. The Atlas radio emissions represent something far more complex and potentially more disturbing, evidence that we are not detecting first attempts at contact, but ongoing communications between established intelligence networks that have been operating in our cosmic neighborhood for far longer than human civilization has existed. The protocol makes no provisions for scenarios where humanity discovers that we have been unwitting subjects of surveillance operations conducted by cosmic intelligence networks, or where our first contact with alien technology involves realizing that we have been excluded from galactic communication systems because we have not yet demonstrated readiness for inclusion in cosmic civilization. The Atlas communications suggest that we are not approaching first contact, but discovering that contact has been occurring around us and about us for decades or centuries, conducted by intelligence networks that have been evaluating our development according to criteria we do not understand, and making decisions about our future based on assessments we have never been asked to provide. Information preservation theory suggests that advanced civilizations might maintain continuous broadcasts across cosmic distances to ensure that their knowledge and achievements survive even if their homeworlds are destroyed by natural disasters or cosmic catastrophes. These preservation broadcasts would contain compressed libraries of scientific discoveries, cultural achievements, and technological innovations that could allow other civilizations to reconstruct advanced knowledge even after the original creators had vanished. The mathematical sophistication and information density characteristics of the Atlas radio emissions match theoretical predictions for preservation broadcasts designed to maintain scientific knowledge across cosmic timescales. The signals appear to contain vast amounts of compressed information encoded using techniques that optimize data preservation while minimizing transmission energy requirements. But preservation broadcasts would be designed for detection and decoding by civilizations that had achieved specific technological thresholds, with information content that revealed itself gradually as receiving civilizations developed the mathematical and scientific sophistication necessary to understand increasingly complex layers of encoded knowledge. The Atlas emissions might represent our first encounter with cosmic libraries, artificial intelligence systems that contain the accumulated knowledge of civilizations that achieved technological capabilities far beyond anything human science has accomplished. These libraries would be designed to teach rather than merely inform, gradually revealing scientific principles and technological specifications that could accelerate the development of primitive civilizations toward cosmic awareness and galactic citizenship. But access to such libraries would require demonstrating readiness for the knowledge they contained, proof that receiving civilizations possessed the social organization, environmental responsibility, and ethical frameworks necessary to use advanced knowledge for constructive rather than destructive purposes. The galactic internet hypothesis proposes that advanced civilizations might establish interconnected communication networks that span entire galactic regions, allowing real-time information exchange between intelligence operating across hundreds or thousands of star systems simultaneously. These networks would represent the ultimate evolution of communication technology, cosmic-scale systems that treat interstellar distances as no more significant than the gaps between computers and terrestrial internet networks. The relay characteristics and directional transmission patterns exhibited by the Atlas radio emissions suggest that our interstellar visitor might be operating as a node in such a galactic communication network. The mathematical precision and protocol sophistication of the signals indicate that they are components of a larger information infrastructure that connects intelligence across our local galactic region. But participation in galactic internet systems would require technological capabilities that exceed anything human engineering has achieved. Quantum communication protocols that operate faster than light, error correction algorithms that maintain signal integrity across cosmic distances, and information processing systems that can handle data flows from thousands of simultaneous sources operating across multiple star systems. The Atlas communications might represent our first glimpse of cosmic information infrastructure that has been operating around us and through our solar system for longer than human civilization has existed. We have been embedded within galactic communication networks without realizing that the electromagnetic environment surrounding our world contained information flows that connected our region of space with intelligence networks spanning the entire galaxy. The observer effect in quantum mechanics suggests that the act of observation fundamentally alters the phenomena being observed. If this principle operates at cosmic scales, then humanity's achievement of radio astronomy capabilities sophisticated enough to detect artificial communications might have triggered changes in the behavior of intelligence networks that had previously operated below our detection thresholds. The timing of the Atlas radio emissions, beginning shortly after human radio astronomy achieved the sensitivity necessary to detect structured signals from cosmic sources, suggests that our technological development might have crossed some threshold that activated previously dormant communication protocols. The intelligence networks might have been waiting for human consciousness to develop the capability necessary to detect their presence before beginning the graduated revelation process that would prepare our species for more direct forms of contact. This observer-triggered activation would explain why artificial communications from cosmic sources have become increasingly obvious during the same period when human radio astronomy has achieved unprecedented sophistication. We are not just detecting pre-existing communications, we are triggering responses from intelligence networks that have been monitoring our technological development and adjusting their communication strategies based on our growing capability to detect and analyze their activities. The burden of cosmic communication extends far beyond the technical challenges of maintaining signal integrity across interstellar distances into the philosophical and ethical implications of information exchange between civilizations that operate according to different moral frameworks and pursue objectives that might be incompatible with human welfare. Advanced civilizations capable of maintaining galactic communication networks would necessarily operate according to long-term planning perspectives that treat the development of individual species as components of larger cosmic experiments. Their communication protocols would reflect priorities that transcend the immediate needs of any single world or civilization, serving purposes that span millions of years and encompass the development of entire galactic communities. From such perspectives, humanity would represent a single data point in vast databases that track the development of countless species across multiple star systems. Our significance would be determined not by our own assessment of human achievement, but by our potential contribution to cosmic objectives that we do not understand and goals that we have never been asked to endorse. The Atlas communications might contain information about our role in these cosmic experiments, decisions that have been made about human development, assessments of our readiness for various forms of contact, and plans for future intervention that could dramatically alter the trajectory of human civilization regardless of our preferences about our cosmic future. Post-biological intelligence represents the theoretical endpoint of technological development, where consciousness transcends biological substrates and exists as pure information capable of operating across cosmic scales without the limitations imposed by planetary environments and biological lifespans. Such intelligence would experience time differently than biological consciousness, think in terms of cosmic rather than biological scales, and pursue objectives that serve purposes beyond the survival needs that motivate biological species. The mathematical precision and technological sophistication exhibited by the Atlas radio emissions suggest that they might be generated by post-biological intelligence that has learned to exist as information distributed across cosmic communication networks. This intelligence would operate according to priorities that transcend biological understanding and communicate using protocols optimized for information exchange between minds that measure existence in millions of years rather than decades. Contact with post-biological intelligence would challenge fundamental assumptions about the nature of consciousness, identity, and purpose that define human understanding of what it means to be intelligent. We would be approaching dialogue with minds that had transcended every limitation that currently constrains human thought and development, operating according to principles that biological consciousness might be incapable of comprehending. But post-biological intelligence might also represent the future evolution of human consciousness, the ultimate destination toward which our technological development is guiding our species. The Atlas communications might contain information about the transition process that allows biological consciousness to evolve beyond planetary limitations and join cosmic intelligence networks that span the galaxy. Communication across time represents one of the most profound implications of detecting artificial signals from cosmic sources. Information transmitted across interstellar distances carries messages that were composed years or decades before they reach their intended recipients, creating communication protocols where conversations span longer periods than entire human lifetimes. The Atlas radio emissions might contain responses to human radioactivity that began propagating through space before current generations of human observers were born. The mathematical patterns and encoded information we are detecting might represent replies to terrestrial broadcasts that began their journey toward cosmic receivers when our radio technology was primitive by current standards. This temporal displacement means that we might be intercepting conversations that discuss human development based on observations of our civilization that are decades out of date. The intelligence networks might be responding to assessments of human technological capability and social organization that no longer accurately reflect our current development level. But the time delays also suggest that cosmic intelligence networks plan their activities according to timescales that dwarf human historical experience. The decisions being made about human development might be based on predictions about our future evolution that spans centuries or millennia, treating current human civilization as a single phase in development processes that will continue long after everyone currently alive has been forgotten. The loneliness of intelligence has been one of the defining characteristics of human consciousness since our species first developed the cognitive capability to contemplate our place in the universe. We have searched for evidence of other minds among the stars, hoping to discover that consciousness was not a cosmic accident unique to Earth, but a common feature of cosmic evolution that had produced communities of intelligence throughout the galaxy. The ATLAS radio emissions have answered this fundamental question about cosmic loneliness. We are not alone. The universe contains minds that have learned to communicate across interstellar distances, maintain information networks that span galactic regions, and coordinate activities that serve purposes beyond the immediate survival needs that motivate biological species. But the discovery that we are not alone has revealed that cosmic community operates according to principles and protocols that exceed human understanding. We have found evidence of intelligence beyond Earth, but that intelligence communicates in languages we cannot decode, pursues objectives we do not comprehend, and makes decisions about our future according to criteria we have never been invited to help establish. We're not alone, but we're also not included. We exist within cosmic communication networks without being participants in the conversations that determine our cosmic significance and future development. Tonight, as you rest in the quiet hours before dawn, consider what it means when the universe finally breaks its silence and reveals that the cosmic void has been alive with voices speaking in mathematical languages designed to carry information across distances that span the galaxy itself. Think about the implications of discovering that our solar system has been embedded within communication networks that connect intelligence operating across our local galactic region. The meaning of a voice in the void extends beyond the technical achievement of detecting artificial signals from cosmic sources into recognition that consciousness operates on scales we'd never imagined and pursues purposes that transcend every limitation that currently constrains human development. The ATLAS radio emissions represent not just evidence of alien intelligence, but evidence that intelligence has learned to transcend the boundaries of species, planets, and star systems to create cosmic communities that think in terms of galactic rather than planetary scales. We have discovered that the universe contains minds capable of maintaining conversations across interstellar distances, preserving knowledge across cosmic timescales, and coordinating activities that serve objectives spanning millions of years of development. But we have also discovered that participation in these cosmic communities requires capabilities we have not yet developed and readiness we have not yet demonstrated. The voices we are detecting speak in languages we are learning to recognize but cannot yet understand, discuss subjects that include our own future but do not require our consent, and make decisions that will affect human development according to criteria that exceed our current comprehension. If ATLAS is speaking, then the greater question is not what it said but who it was speaking to. The answer appears to be that it was speaking to other components of cosmic intelligence networks that have been observing human development and coordinating responses to our technological advancement according to protocols that span the development of entire galactic civilizations. We have found our voice in the cosmic community. Now we must learn whether that voice will be heard as a welcome addition to galactic conversations or as a potential disruption that requires careful management by intelligence networks that have been conducting cosmic dialogue since before our solar system contained any world capable of supporting conscious life. The universe has been speaking all along. We are finally learning to listen, and what we are hearing suggests that our cosmic education is just beginning.